In today's class, we will learn about what is learning curve analysis. Learning curve, the concept is based on the saying that practice makes a man perfect. So every time the work, when it is repeated, it takes less amount of time than it took the previous time. So that is the concept based on which we have this learning curve theory given. But this is applicable, or this is works out in situations where, see, if we have the units here, the output here, and then the time is given here. If it is time on the y-axis, initially if it takes this much amount of time, somewhere here, it keeps coming down until it comes to a particular point. It doesn't go below x-axis. So that's the concept. But then this concept of the average time reducing is applicable only when the output is cumulated. What does it mean by cumulated? Let's say that for the first time when the work is done, 1 unit is produced. So some 100 minutes is required. Then this one should be cumulated. The next time when we are saying that the time reduces, but how much does it reduce if we have to test that? The quantity should be doubled, cumulated. And then this cumulated 2 should be cumulated further, doubled it to 4. Then 4 becomes 8, 8 becomes 16, 16 becomes 32. So this is the situation in which this learning curve analysis or learning curve theory is applicable. So it is not incremental unit of 1, 2, 3, so on, but it is when it is cumulated, the cumulative average time per unit that falls at a particular learning rate. So what is the learning rate? The learning rate is some percentage which is observed from the past record. When they observe that, or how the time taken was reduced, so they build it on that. So from the past data, they build a percentage. Let's say that it takes at the rate of 80%. So the decrease in time would be to the extent of 80%. So when the quantity is cumulated, the average time, it next time when the work is done, it will not take 100 minutes, but it will take 100 into 80%. So that would be only 80 minutes. Next, when the quantity is cumulated, so 80 into 80%. So 80 to 80% gives us 64. Then it goes on 64 into 80%. So whatever is the time, it reduces in that particular fashion. So initially, if it took 100 minutes, then it will be 80 minutes, then it 64 minutes, and 64 into 8, 51 minutes or something, it comes out. So it goes on reducing like that. So that's the concept of a learning curve. So what is the point here? So when the time taken is reduced, so the cost also will be reduced accordingly. It is not always the same at a particular rate or the particular amount for this many number of units, because the average time which is required when 1 unit was made, 100 minutes per required, or 100 minutes per use. So when 2 units are produced, the cumulated 2 units are produced, each unit requires 80 minutes. Then when the quantity is cumulated to 4, each unit requires 64 minutes. So it goes on like that. The learning rate also differs from industry to industry, business to business. The nature of production is important. So depending on that, how much ever time it is required, will be understood from the past observations, or a similar some similar business in the industry or similar firm in the industry. From their performance, how much time was required can be understood, and that's how it is estimated. When learning curves are applicable, when are they applicable? When the process is labor intensive, it is not automated, because automated work is carried on at the same speed, at the same rate. There would be no decline in the time taken. But this is applicable only when human beings are applied, human beings are put to use. So the process is labor intensive. The product is a new product. The product is complex. The product is repetitive. There are no breaks in production. So then learning curves and a steady rate. The learning curve effect will only apply for a certain range of production. So it comes down to only a particular point and then it stops. It doesn't go below that. Okay. For example, machine efficiency may restrict further improvements, or there may go slow arrangements in place. So it doesn't fall down below a particular point. Only once the steady state is reached, the direct labor hours will not reduce any further, and this will become the basis on which the target is produced. Eventually, the learning effect will cease, and the time to make successive units stabilizes us at a constant time per unit. Let's go to the exam kit and take up the questions on learning curve analysis. We'll work one or two questions which are there. The question on the screen, 163, the time taken to produce a batch of 50 units was 500 hours. The total time for the first 16 batches of 50 units was 5731 hours. What's the learning rate? We are asked to calculate what's the learning rate. See, when the first unit were, the first batch of 50 units were produced. So, if we are looking at the work taken up in batches, okay, the first batch of 50 units when they were produced, um, the time taken was 500 hours. The total time taken was 500 hours. First batch of units. So the average time is also 500. Then this will be accumulated. Then it again gets accumulated. Then 8. It comes down to 16. So that's what is given. When 16 batches of 50 units were produced, we're asked to find out what is the learning rate. So the 16 batches of 50 units when they were produced, the total time taken was 5,731. How does the average time reduce? The average time, now the learning curve is a decreasing trend. It reduces. The first time if it was 500 hours, these 500 hours will reduce by a learning rate. So that learning rate is not given to us. The learning rate is what we have to calculate. So learning rate, let the learning rate be R rate or L or something. Okay. Let so what happens? The next time it will be 500 into R. After that, this will be 500 into R into again R. So this would be rather R square. Now here it will be 500 into R cube. Then we see 500 into R to the power of 4. So let's say, for example, whatever the previous example which I have scribbled on the screen, let's assume that 1, 2, 4, 8. If this is the case, if it requires 100 minutes, and if, for example, the learning rate is 80%, if the learning rate is 80%, we see that every time when the work is done, it will be only 80% of the time taken. So here it will be 100 into 80%. Let me put it this way, 100 into 80%. So here it will be next 80 into 80%. So here it will be 80 into then 64 into 80%. Then it goes on like that. So what are we basically doing? Whatever was the previous value into R is the rate. So that is how we calculate. So for the first time when we see the time taken is 500 hours for the first unit, or it is batch in batches. So batches, each batch consists of 50 units. That's what is mentioned. This basically we can talk it about as batch. Every batch consists of 50 units. That's the point. So the time taken for the first time is 100 or 500 here. Here it is 100, it's 500. So 500 into rate. Rate we do not know. That is what we are asked to calculate. So into R. Then 500 into R into R. 500 into R into R into R. It goes on like that. So now can we substitute? We see 5731 into is equal to 500 into R to the power of 4. Just calculate that and then check that. Total time is equal to number of batches into average time per batch. This part is equal to 5731. So total time is 5731. 5731 is equal to, we got the average batch, average time per batch as 500 into R to the power of 4. But then how many total number of batches? That is 16 batches into 500 into R to the power of 4. Simplify that. R to the power of 4 is equal to 5731 divided by 500 into 60. Check how much is that? Two times find out square root if it's possible. So R is equal to 92%. I hope you got the point. 165. The time taken to produce the first unit produced was 100 hours. The time for the second unit was 90 hours. What's the learning rate? It's only two things which are given. So the first one is 100. The second unit, the time for the second unit was 90 hours. So in that case, um, how do we calculate what is the learning rate? See, we have the first unit required. This is every incremental unit, every additional unit which is mentioned. The average time for the first unit produced was 100 hours. The average time for the second unit produced was 90 hours. So, how much is the total time? When we accumulate it up, we get the total time is equal to, for the first one, it is 100. For the second one, it is um, this is time. This is average time. Because it's the incremental time which is given. So average time will be, for the first time it will be 100, second it will be is equal to 190 divided by 2, 195. 100 is equal to for the second time when the average time is calculated, 95 would be the result of is equal to 100 into R. So R will be R is equal to 95 divided by 100, which is equal to 95%. We'll take one more question. The time taken to produce each of the first four batches of a new product were as follows. Batch is 1, 2, 3, and 4. Time taken is given as 100 minutes, 70 minutes, 59 minutes, 55 minutes. What was the rate of the learning closest to 2? So let's start. Okay, sorry about that. Batches are given. How are the batches given? Batch 1, it is not cumulated. Do we see that? We see that this is incremental. It is not cumulated. 1 has become 2, 2 has become 4. That is not the case. But the time map for the individual batches are given. Time taken is mentioned as 100 minutes. Then we have it as 70 minutes. Then we have 59 minutes and 55 minutes. So the total time which is taken would be total time is equal to the total time when it is added up, it comes down to 284. See, this learning rate is applicable when it is cumulated. So when we cumulate it, basically, how many times would it be cumulated? 1 becomes 2, 2 becomes 4. So the total um, 284 would be 284 is equal to, see, the cumulation when